Azra, the weather today is so nice.
Yeah, it's a very sunny day. That's why we take picture.
An eternity later.
Azra, have you ever thought there is no other color than green in this leaf?
I'm not very sure. But I just stumbled with some video on YouTube. Let's have a look. I will talk about this green pigment first, which is known as chlorophyll. Chlorophyll is the abundant pigment in the leaf that divided into two types of chlorophyll, which is chlorophyll type A and chlorophyll type B. For chlorophyll type A, it is the main pigment involved in photosynthesis, absorbing mostly blue, violet, and red light. However, for the chlorophyll type B, it is an accessory pigment that complements chlorophyll A by absorbing light in slightly different range, primarily blue and red-orange light. Next, I will talk about this pigment, which is known as carotenoid. Carotenoid exists alongside with the chlorophyll. This pigment produces yellow, red, and orange color on leaf. Carotenoid divides into two types, which is beta-carotene for yellow-orange color and xanthophyll for red-orange color. However, this pigment is least dominant and masked by chlorophyll, so we rarely see them on leaf. Other than that, I will talk about this pigment, which is known as anthocyanins and produce red, purple, and blue color. This pigment is not always present in the leaf and often appear only on certain conditions, which is high light level and cool temperature that affect the pH level. Last but not least, I will talk about this tanning pigment. This pigment is always associated with autumn season. This is because this pigment causes the leaf turn into brown color due to chlorophyll breakdown during autumn season. So, this explains why we can see variable color of leaves during certain season. For example, during autumn, chlorophyll breakdown resulting other pigment to more visible and cause beautiful array of fall color. So, in order to determine all this pigment in leaf, we can do paper chromatography experiment. But it will explain later.
Hey, is that Azra and HAZIQAH?
Yes, let's go to them.
Hey, what are you guys doing? You guys seem like thinking so hard.
Yeah, we just thought about the method of how to do the chromatography thingy.
Oh, I actually know.
Oh, is that so?
Yeah, let's have a look.
Hi, so right now I will explain the methodology on how we did the experiment. So first, obtain your plant leaf containing the pigment and then add a few drops of acetone along with a little sand to help with the grinding up the leaf. Thirdly, grind up the leaf with pestle and mortar. Fourth, draw a pencil line 2 cm up on the chromatography paper. And then create a concentrated spot on the pigment on the line. And then pour a running solvent into the container for your chromatogram. And to ensure that the solvent does not go above where the pencil line is on the paper. 7. Place the chromatography paper in the container gently. 8. Wait and allow the solvent to move up the paper carrying the different pigment with it. Also, it is important to keep an eye on the solvent front because it will stop at the different distances relative on how far the solvent front goes. 9. When the solvent front has stopped moving, remove the paper. And then, with a pencil, mark the edge of the solvent front immediately. 11. Mark the front edge traveled by each pigment. And why do we have to mark the front edge traveled by each pigment? The purpose is to measure how far each pigment or each color moves from the point of origin. And then, in order to identify the pigment, we have to calculate that the RF value for each pigment that we found in the chromatogram.
That is all. Easy, right?
Wow, how do you guys know all that things?
Actually, Iman and I just did the experiment last week. Do you guys want to know the result?
Yes, let's go.
When we ran this experiment, we got 3 component color, which is slightly green, green, and yellow. For the RF value, we got for slightly green is 0.7, green 0.9, and lastly, for yellow 0.98.
From the result we obtained in this experiment, here, We got to see that the pigment consists of 3 colors, which are slightly green, and yellow. Also, in this experiment, we use paper chromatography technique.
Based on the video, they use paper chromatography to spread pigment in leaf and determine the color in pigments. The chromatography is used to spread the components of a mixture based on the difference in the rates at which the mixture is carried out through a stationary phase by the mobile phase. In this video, the stationary phase is chromatography paper itself, which contains polar in liquid form containing H2O, which pass over the stationary phase that carries the component, and the mobile phase is the running solvent. In this video, they are not mentioned in detail which chemical it is. So, we predicted the running solvent is 9 part petroleum ether and 1 acetone.
Based on the result here, component color for the slightly green is strongly retained or absorbed by the stationary phase and making this color move slowly with the flow of the mobile phase. Meanwhile, for the green color, is between held by the stationary phase, where it travels fast following the mobile phase. Lastly, for the yellow color, is they are weakly held by the stationary phase, so it travels fast following the mobile phase compared to slightly green color. But how we want to know the distance of these separation components? Actually, we can know the distance by calculated using formula RF. But what does RF means? Don't worry, I got you. Actually, RF is distance moved by the pigments divided by distance moved by the solvent front. To summarize this experiment, we do comparison between yellow color and slight green color. The RF value we calculated for yellow color, which are 0.98, shows that the higher the RF value, meaning that the stronger it is held or absorbed by the mobile phase. Meanwhile, the RF value for slightly green spots, which is 0.7, as it absorbs more to stationary phase.
So, why the different pigment can have a different distance? A chromatography where the analytes are separated based on their different degrees of absorption on a solid stationary phase. In the absorption process, the solute molecules are attached on the surface on the stationary phase, which is solid. The separation of solute depends on the difference in polarity. The more polar solute are more readily absorbed onto the stationary phase than the less polar solute. Thus, this polar solute will move slower, while the less polar solute will move together with less polar or non-polar mobile phase. In this experiment, a mobile phase is a non-polar, which is the running solvent solution, which are used to absorb the different types of pigments being separated. On the other hand, chromatography paper is the medium which contains liquid H2O. They are polar, which pass over the surface that carries the pigment. Basically, if the pigment have a high polarity, it will be more attracted to the stationary phase, which is the paper. Because paper contains some absorbed water, creating a highly polar environment. Thus, the pigments with a lower polarity will be less attracted to the stationary phase. So, it will be more attracted to the mobile phase and travel further because it is weakly held by the stationary phase.
For the conclusion, in conclusion, paper chromatography performed on leaf is used to separate the pigment they contain. This process allows us to determine the solubility of each pigment based on the distance each spot travels on the filter paper.
Thank you. Because of you guys, I learned new things today. You guys saw too, right? Me too.
Me 3. Me 4.
That is all from us.
Thank you.
Okay lah, I nak sambung OT dia lah.